All right, so right now I'm going to go through and do all of the problem ones from the different four tests. And problem one is just about face and vertex coloring. So these ones aren't too bad. So starting off here, we have the face and edge chromatic number. So I always like to do the edge chromatic numbers because I find that they tend to be a little bit easier. So the way to do the edge chromatic numbers is to find the maximum degree. And here we can easily see that this has degree 4, right? And a lot of other places have degree 4. So what we can argue for B is that the max degree is 4. So the chromatic number of the edges is going to be greater than or equal to 4. And that's by some theorem, right? So what we can start to do is just take any vertex of degree 4. I guess we'll choose this one. We can just start coloring the edges. Choose red, why not? And green, sure. So then we just sort of have to choose another one arbitrarily. So I guess we'll just choose this. Usually I have to um, erase something and start over again because I'll accidentally use a color twice. But hopefully we'll get it on the first time. So you just keep doing that, and I always go with the greatest degree of vertices first. So I start with one of degree 4, then go to another one of degree 4, and then we'll go to the last one of degree 4. So what other ones can we do there? Pink we haven't done yet, so we can do pink here, and then we can do, not red, we can do green here. So now moving into the inner part, we can do red and pink. So we could do pink here, and then we could do pink here, red here, and then blue here. And that is an edge 4 coloring, as we can see there. And we knew that that was possible because of the theorem, which tells us that based on the max degree, we have a lower bound. Anyway, for the face chromatic number, you always need to keep in mind the unbounded face. So a really easy trick for this is to say, okay, how many faces are there on the outside? So we'll use completely different colors for this. We'll use light blue. So the outer region is going to be blue, but the outer region touches 3 faces. So we know that there are 4 mutually adjacent faces. And likewise, this inner part here also has 4 mutually adjacent faces, so we can't do any number that's less than 4. So then with here, we'll do orange for that, and then we can do purple here, and then we can do, running out of good colors, we just use this dark red, and now we're moving inner, so do blue here, and then we could do dark red here. And now, wait, this is where the fun part comes in. No, I think what I want to do is I want to do purple here. I think that's a different purple, but it's okay. And then we can do red here. And that's a valid face for coloring. And yeah, so that's the first problem. So the justification we would use would be mutually adjacent faces is equal to 4. And we have a coloring of 4, therefore, there we go. So now for the second test, similarly, this is going to also have a face 4 coloring, as we can see, based on the unbounded face and then the 3 faces on the outside. But let's do the edge 4 coloring. Sorry, the edge coloring. Spoiled the surprise. It's also 4. I guess we'll do the edges in the pastel-y colors because, have a better distinction, I guess. So we use that green color, so red color, pinkish color, and then this blue color. Wait, I should not have colored that edge. What am I doing? Here we go. And I guess we'll just change it up and use yellow. So then we'll move on to another vertice of degree 4. I guess we'll choose this one. So I'm going to do yellow here. Then I will do, I can choose red and green. We'll choose red because for this bottom area because I can't choose green. Then we will choose green for this. And finally, moving on to the last one. Well, we can either use yellow or blue. We can't use yellow on the inner part because it would touch another yellow edge, so yellow has to be the outer one. And then blue can be the inner edge, and that's all good. And now we just have to link this all together. So I think we can do blue up here. Then we could do red over here. Okay, so in this case, we aren't able to do anything, so we need to cycle around some of the colors. So I'm going to get rid of the blue edge here, and I'm going to instead put a green edge there. And then I can put the blue edge down here, and that is an edge for coloring. And similarly, the justification is that the max degree is 4, so the edge is going to be 4 or more coloring. And he's always going to give us a 4 coloring, so we can just go based on that. Anyway, now for the face coloring. So we'll start here. So we can just arbitrarily assign this. Now, every face this touches has to have a different color. So we can say, all right, this face will be blue. And now we can also make this face blue. But we can't make this bottom face down here blue. So we have to choose another color. So let's choose green. So this face down here is green. And now we can make this face here pink. And this face here green. So that's all nice and good. However, we're forgetting the unbounded face. So with the unbounded face, it's actually going to be 4. So you always got to remember the unbounded face. Kind of ruins everything, but face 4 coloring because of the unbounded face. You could do it with 3 if not for the unbounded face. But anyway, so moving on to this one. This one's a pretty simple one. I believe we had this exact one in our homework. So we can do the edges like so. So again, the max degree is 3. So we know we're going to have an edge 3 coloring. Could be more, but he's not going to do that to us. So color that, and color that, and then let's color that. And here's where we realize that I may have done something wrong. So I think what we could do instead is, wait, I'm using the wrong colors. Set top and bottom to be that. And then, there we go. That's an edge, what do you call it? That is an edge 3 coloring. And now, likewise, we can do the faces. So start off with this face here. Now there's 3 mutually adjacent faces, so we need at least 3 different colors. So we'll choose blue, and then I guess we'll choose green. And now we can use pink again, so that's cool. However, this is where the fun part comes in. Again, it looks like it's a 3 coloring, but forgetting the unbounded face, which just kind of ruins everything again. You could have 3 coloring if not for the unbounded face. But there you go, 4 coloring. Anyway, here is the last one. So this one, we can do the edge coloring first. This one has degree of 4, so we're going to have to deal with the fun of degree 4. these colorings are always the most fun ones because there's a lot of variety, and usually that means that there's a lot of chances for you to redo them. So start off by coloring just any arbitrary vertex of the max degree because we know that we need that many colors. So we can start there. Then we can go on to another degree, another vertex of the same degree. So we'll choose that vertex, and we can color this edge green because purple and blue aren't green. We can color this one red. And then the only other edge here has to be blue. So we'll make that blue. Then I guess we'll move on to another one here. So this edge can be blue because of the one we just made. But this edge can be blue. So we'll make that one blue. Then the only other option is purple. So set that to be purple. And now all of the vertices are actually one color. So this is interesting. So we can't do purple here or here. So make this one purple because the other two can't be purple. So then there's green. This one can't be green, so this one has to be green. And finally, red is only able to be this one. And that's an edge 4 coloring. Basically, with all of the edge colorings, start at a max degree and go to other vertices of the same max degree, and then just keep going down and down because there's more options when you get to the lower degrees. But when you're at a degree of 4 and the max coloring is 4, then you just sort of need to cycle around those 4 before you get one to work. Anyway, now we're going to do the face coloring. So again, we'll start arbitrarily with pink, and then we can go to other faces. Now all of the faces are a triangle, which makes our life kind of easy. So this face here can be colored a different color, but notice that this face here also can be colored blue because these two blue ones don't share a common boundary. And then we can color this one pink. And similarly, this one can be pink too. So can this one. And then this one can be blue. And finally, the face at infinity can also be blue. So that one actually is able to be colored with just 2 colors. And the reason for that is because all of the degrees are even. There's some theorem in the book that tells you about that. But yeah, so that's how to do problem 1.